In this video, what we're looking at is the professional standards which exist in the computing industry. And there's a number of different types of standards, and we're just going to look at some examples of each of those types. So one of the first things which we can look at is computer code. And one of the nice things, this is both in Python, and both these snippets of code do exactly the same thing, both of them work. One of the things about Python is it does force you to have nice indentation. Some languages don't, so one of the professional standards would be that your code is correctly indented. One of the things which goes wrong in this code is we've called things A and B. We're asking someone their name and their age, and then we're storing that in variables called A and B. It would be much better to store it in something like name and age. And it means when we get to this if statement here, we're saying if B is less than or equal to 19, it's much less meaningful than saying if the age is less than or equal to 19. So variable names being meaningful, and indentation, which we're forced to do if we use Python but not other languages like C#. And one of the other things is spacing, which is similar to indentation. So here there aren't spaces around the less than or equals to, there aren't spaces around the assignment operator, the greater than equals operator. Whereas in this one there's nice spaces around them, which just makes it easier for other programmers to read. And that's the exact reason why we have these standards, why people have agreed that there's better ways which they can write code. Just as we have full stops and commas in English, we have ways in which we write code which make them look better, and it's to make it easier for other programmers to understand. And it really is as simple as that. To a computer, these are identical bits of code. It doesn't matter either way, but other programmers have to read your code. You have to go back and read your code, and so making that as easy as possible to understand is vastly beneficial. The next types of standards that we have is for manufacturers and also software developers. So these are often ISO standards, which is an industry standard, international standard. And an example of this would be ISO 9660, and this is the standard for CDs. So all that ISO 9660 is saying is the way in which files or music is stored onto a CD. And the reason that you have a standard for it is you could have lots of different competing companies all producing their own music disc, and you wouldn't be able to use any of those in different hardware. So rather than having lots of different people competing with lots of different standards and no one really gets anywhere, ISO 9660 says exactly how this should work, and it means, and the advantages of doing this are that manufacturers and developers, so that could be people producing software as well, have a standard to work to for interoperability. And all interoperability means is that different software and different CDs will all be able to work on CD players that conform to this standard. So it just makes it much better for the end user, and it makes it cheaper for manufacturers to develop because they know that they're going to have a large market for their products. The next type of standard that we have is standards in languages and the way that they are interpreted. So there's an organization called the W3C, and these are the World Wide Web Consortium, and these create the standards for languages such as HTML and CSS as well. HTML is hypertext markup language. So this is the language of the web and websites, and this language specifies how websites, what the information is on a website. The web browser can then read that HTML because it's an open standard. It can read the HTML and determine how the web page is going to be displayed. So the advantage of having an open standard here is that we can have many different web browsers conforming to one standard. So I don't have to make a web page for Chrome and for Internet Explorer and for Firefox and for Safari. I make one web page in HTML, which is a common language, a standard language, and then any web browser is able to read that. And indeed, if you were using the HTML standard as opposed to something which wasn't a standard, even if you were using it back 10, 20 years ago, those web pages would still be readable even on mobile phones today. So it's a much better way of doing things to have an open standard. Moving on a little bit from HTML, there's also standards in accessibility. So certain people may not be able to read text because they're blind or they've got difficulties with their sight. So some of the accessibility standards within HTML, if I create an image tag, so this is saying add into my web page an image, and the source location of that image will be, we'll say, tree.jpg, so it's a JPEG image. And then for accessibility, we add in another attribute called the alternative attribute, or alt, and I can put something like an oak tree. So this line of code here, or this tag, is adding in this image, and it will put that into a web page, but it's no good having an image if somebody can't see. So they have a text-to-speech which can read out the text, but it can't read out an image. So by adding in this alternative here, I'm saying this is an oak tree, and then if someone has text-to-speech and they see the, well, they won't see the image, but if the image is there, it can then read out there is an image of an oak tree. There are also standards for how software is actually developed, and one of the most famous standards is called the waterfall model. And so what the waterfall model says is a methodology in which we can develop software, and we start off with a requirements specification. And so you would go to an end user, you would go to a company, and you would say, what do you want this software to do? And point by point, you would list every single point that that software is supposed to do. You then go away and you design the software. So that's not making it, that's designing it. So you put a design onto paper, you show what the screens will look like, how the software will flow, maybe what the algorithms will be doing underneath. Then comes the implementation. And this is also known as coding, so this is actually creating the software itself, the computer code that's going to run. The next phase is known as either verification or testing, and I'll put testing because it's a slightly easier word to understand. So having written the code, you now run it on the system and see, does this actually work the way I intended it to? Does this meet the specification? And if I put in data which is strange, will it react the way I expect it to? And finally, after that comes maintenance. And this is maintaining the software, so if there's any problems that develop which you hadn't found in testing, then you maintain that software and possibly release updates, or you help the users of the system in training them or assisting them in using that software. And this is quite a traditional way of creating software, a very formal way of creating software. Another method of software development is to use something called RAD, or Rapid Application Development. And what Rapid Application Development does is it works much more closely with the user and in a much faster iterative way, so it's going more in a spiral than a waterfall. And so what you've got is, at the beginning, you've got the requirements or the planning. And this won't be quite as specific as the waterfall method. It won't necessarily be a list of exact requirements. It'll be a general idea of what you're going to produce. And then the next phases will be user design and the construction. So this is the creating of the code. And this will go almost hand in hand. And in fact, in this phase, we will be going round and round with the user design and the construction. So as we design things and test them out and make them, we might decide, actually, I want to change that a little bit. It's not doing exactly what I wanted. Or I've got a new idea as a result of something I've seen. I've got a new idea which I'd like to be incorporated in. And then at some point, having gone round and round in this rapid application development model, we will then get to a point where we're happy, and this will be the cutover point. And this is when we end the development of our computer model or our computer program. Another area which is important for professional standards of computer users as well as those that work in industry is that of policy. And one of the areas, so you may have, for example, the law which says that you can't hack someone's password. That will be the Computer Misuse Act. However, policy is also very important. It's perfectly legal for you to leave a company computer not locked, so someone else can come and use that computer. You're not breaking any element of law by doing that. However, a company policy may decide that the company doesn't want you to leave computers unlocked because someone else can come along and use them. So a company policy may, for example, say that at all times you must lock your computer. And this would be a very sensible thing for a company policy to say. It may also say things like an acceptable use for email. And that might be the style of emails that you write. And the reasons that people will put in these policies are fairly obvious. What they're trying to do is to create safe and secure systems, and people are very involved in making systems safe and secure. It's not just law. And what's also important is that the company is keeping their information safe. And in the case of the email or website or the language that you use, it's also keeping the company or corporate image respectable. The final thing that we're going to look at is the maintenance of computer systems. And the maintenance is, once you've released the software, once you've got the computer system working, maintaining that in good working order. And so maintenance of a system may involve replacing hardware that fails. Maintenance undoubtedly will involve security updates. Some of these might automatically update themselves, such as in your operating system that you use at home. Some of them on software you may have to actively go out and find, is there a security update, and regularly you'll be doing that, or you'll be receiving emails to tell you that there is a security update which you need to install. It might be that you keep the latest versions of software which has bug fixes and makes it more stable, more reliable. And obviously you're going to be updating things like antivirus software. And the reason for this maintenance stage is to keep your system reliable, and it's to keep it secure, and it's to keep it stable.